Okay, welcome to Balancing Equations. There's another video on this channel that's the basics of balancing chemical equations. This one will balance the reactions that you had to in your test, one of which is really tricky. So your goal, of course, is to obey the law of conservation of mass. Everything you start with has to equal everything you end with, but just rearranged. So you might have 6 hydrogen atoms before the reaction, and you'll have 6 hydrogen atoms after. Might be that before the reaction it's 3 pairs of hydrogens, and after the reaction it's 2 sets of 3. But it has to be the same somehow. Your only tool is writing coefficients. When you write a coefficient, it multiplies through that substance. So imagine that number in front multiplying by every subscript, and that's how many of each atom you have. Okay, there were 2 open response questions that had to do with balancing. Okay. 21 was possibly the easier one. It doesn't matter what element you start with as long as you check every element twice. So I could start with the iron, or I could start with the oxygen. If I do that, though, you want to go back and originally check the first guy that you did. So I'm going to start with the oxygen, just because I noticed something about him. Something else to notice is the phase labels just don't matter. You just need to ignore them when you're balancing. So the fact that iron is a solid, that's S for solid, oxygen is G for gas, and it makes solid iron oxide, it just doesn't matter. It doesn't change the quantity of anything. Also, focus on before and after the reaction. So maybe it helps visually to break up your reactants and products. If I start with 2 oxygens and I end with 3, the only way to make these the same is to multiply these numbers by each other. So 2 times 3 is the same thing as 3 times 2. Now I have 6 oxygens on both sides. My oxygens are good. Okay. Now let's focus on the irons. I wrote that too, so now I have to use it. It's written there, I have to consider it now that I look at my irons. So 2 times 2, I have 4 iron atoms. I just have 1 over here, so let's just multiply it by 4. And that works out nicely. Check every element again. 4 irons, 2 times 2 is 4 irons, 3 times 2 is 6 oxygens, 2 times 3 is 6 oxygens. Okay. This is the really tricky one. When I balanced this one, it required me to write a bunch of coefficients and then rewrite them. So maybe write in pencil, erase and rewrite. Do not be afraid to write coefficients and then change them later. I'm going to leave oxygen for last. The reason is that it shows up in 2 of my products. So my oxygen will be changed by writing in either of those spots for coefficients. So writing there or writing there might mess up my oxygens and change what I want to put there. So I'm going to leave the oxygen for last. Let's look at sulfurs and antimonies. And you definitely want to notice that this is antimony, SB, and this is sulfur, S, and don't let them look the same in your mind. The way it is right now, I have 2 antimonies on each side right now. So if I look at my antimonies first, I wouldn't do anything. Okay? That will change, of course. Okay. How about sulfurs? 3 sulfurs, 1 sulfur. Remember, this is an invisible one. So how do I make these the same? How about 1 times 3? Taking the smaller one, multiplying it by a number to bring it up to the same quantity as the larger one. My sulfurs are good right now, at least for now. Total oxygens on the right. I've got 3 there, and 3 times 2, I've got 6 there. Right now I'm showing 9 oxygens on the product side. After the reaction, I have 9 oxygens. They split up. Some of them went in this compound, some of them went in that compound, but they all came from the same place. They all came from this O2 molecule. So I have to account for all of them. Okay, 2 times what equals 9? Well, nothing. Or you can think 4.5, right? But we know that's no good. It's no good to write 4.5. It's mathematically good though. So why don't I write it and then double everything? So this was an invisible 1. I'm going to make it a 2. 4.5 doubled is 9. This was an invisible 1. So double it, make it a 2. This was a 3. So let's double it and make it a 6.
Excuse the interruption. The Cherrydale 9th grade fundraiser, your order